Let me write something down here for you before we get started here. Uh, Tau of n divides n means the very same thing as saying uh, n is equal to some multiple of tau of n. Now, y'all, tau of n, I'm going to end up writing it like t. It just counts the number of divisors of n. Okay, so this statement says the very same thing as saying n is equal to some multiple of tau of n. Okay, like that. Now again, y'all, tau of n counts the number of divisors. For example, tau at 9 would be equal to 3 because 1, 3, and 9 are the only divisors of 9. So that's what tau of n does. A lot of y'all have seen it maybe as little d. Okay, now we're supposed to show that if n is an odd tau number, show that n is a perfect square. Now this is the definition of a tau number. Literally, the number of divisors divide the number itself, that is, as a factor of the number itself, then that number is said to be a tau number. Now, I'm going to show you here that 84 is a tau number. Now, y'all, 84 has this prime factorization. 2 squared is 4 times 3 is 12 times 7 is 84, right? Okay, and so this is a well-known combinatorics result right here. You can just increment each of the exponents. So there's a 2 here, there's an understood 1 here, 3 to the first power, and of course 7 to the first power. And so what you can do is actually increment each of those exponents because you need to account for 0 as a possible exponent. So you get 3. Now you can list all the divisors. That gets a little onerous though for larger numbers. So it's better to work from the prime factorization, generally speaking. So 3 times 2 times 2 is 12. Equals 12. So y'all, we see that that makes it a tau number just by this notation. So this is 12. So what we have here, that's equal to 12. And we see that tau at 84, we've just shown that it's 12. That's the number of divisors of 84, number of divisors. Tau at 84 definitely divides 84. A large vertical bar, and then let's write 84 down again. And that's what we mean by a tau number. Okay. Now, so again, what are we out to prove? We're supposed to show that this is an even tau number, right? We're supposed to show that if n is an odd tau number, that n is a perfect square, okay? Now this blind obvious fact turns out to be actually quite powerful. An odd number has no even divisors, duh. If it did have an even divisor, it wouldn't be an odd number, right? It would be an even number. So anyway, now, so we've hypothesized that n is odd, so that's what this says right here. And also, this is the definition of a tau number that tau of n divides in, okay? Well, if tau of n divides an odd number, then tau of n is odd by this dead obvious fact here, right? Okay, so tau of n is odd, but remember tau of n is the number of divisors of n. And I know a lot of you remember that if you have an odd number of divisors, that always corresponds to a perfect square. Okay, and that's simply because divisors occur in pairs, except in perfect squares where the k would just be one divisor and all the others would pair up and they would sum up to an odd number, right? So we've actually proved the number. T of n is odd by the fact. T of n odd implies n is a perfect square, and so we're QED time. Okay. Now, y'all, we have proven the result, and let's take a look at a list of some of these guys. Okay, now, so these are the first few tau numbers. Now, notice 9 is pretty easy to see, right? Notice that T of 9 is 3, right? T at 9 is 3. Tau, I keep calling it T, I'm getting lazy. But T at 9 divides 9. Right, trivially, and you don't need any calculation there. 1, 3, and 9 are the only divisors, right? So that makes it a perfect square. 9 is equal to 3 squared, right? Now, 225, you see these odd ones are fairly sparse, right? They're all even. We did 84, didn't we? Just back there at the beginning. But notice here, this would be equal to 3 times 3. That's 9 also, right? As before, remember you increment the exponents. And notice that 9 divides 225. It's 9 times, well, obviously it's 9 times 25, right? So we see that tau at 225 divides 225. But really, the more important takeaway here is that this is equal to 15 squared, right? So y'all, I think pretty cool. I didn't know anything about tau numbers until about 3 or 4 days ago. So I hope you're enjoying this as much as me. And that's the completion of the proof right there. And hope you enjoyed.